Hello everyone, welcome back to today's session. Myself, Dr. G. Venkat Nagachandra, Assistant Professor at SR University in the Department of Civil Engineering. Today I will discuss about the introduction to the water supply and its importance to protection. So, why this subject is important? So, why we need to study? What is the role of environmental engineers? So means here we need to supply safe drinking water to the community so that they won't get the kind of diseases. And next point will be the develop skills to the design water and wastewater treatment systems. Then address the urban sanitation and fecal sludge management, and ultimately we can control the pollution. And also it supports the sustainable development goals. United Nations proposed around 17 sustainable development goals. In that sustainable development goal number 6, that is the clean water and sanitation. And next one is the prepare students for the different industries and government projects and higher studies. That's why this subject is most important, and also we need to provide the good quality as well as the quantity to the community. So why means pure water is required. So absolute pure water is never found in the nature, and which contains only two parts of hydrogen and one part of oxygen by volume. But the water found in the nature contains number of impurities in varying amounts. Generally, what are the fresh water existed in the earth surface that will be there in the aquifer. So generally, the aquifer in the water exists in the aquifer. It is due to the interaction between the water and rock surface. In rock generally contains different minerals that also dissolve in the water. That's why if it is excess the pH standard, that will be contaminated. So that's why number of impurities are there. So before taking for the drinking purpose, we need to check the physical, chemical, biological characterization. After that only we can recommend to drink water. So what are the things not should be there for the drinking purpose? See, so water should be free from the bacteria. That is the most important, and it should be colorless and sparkling, and it should be odor free and cool, and it should be free from objectionable matters. Maybe in water contains maybe suspended solids, maybe paper, plastic, some kind of dust particles. It should not be some kind of materials, objectionable materials, and it should not be corrode pipes. And finally it should have dissolved oxygen. If dissolved oxygen is there, the means those water considered as the fresh water. So what is the importance and necessity for the plant water supply? See here, so why means planet water supply is required. Why it is necessity? Means we need to supply sustainable resource management, ensures efficient use and equitable distribution of water resources across the regions. So first foremost thing that we need to supply water to the all community in equal levels, and also we need to supply sufficient quantity. That is called a sustainable resource management. And growing demand. So what is a growing demand? The population is increasing, and also lifestyles are the changes. So due to these patterns, what will happen? The quantity of water is required per day is increasing. So that makes we need to go for the proper planning, proper distribution network. Then only we can supply water to the community in equal level, equal pressure. Then next factor can influence it is the climate change impact. So we already discussed, maybe due to the industrialization, the carbon dioxide concentration on the earth, it will be increased. If it is carbon dioxide increased, the global warming will be happen. The global warming, what is the meaning of global warming? Will be the temperature on the earth surface will increased. If temperature increases, what will happen? The water existed on the water surface get evaporated, droughts will be occurred. Then in some regions ice caps get melted, then floods will occur. This is the extreme cases will happen due to the climate change. Then health and sanitation. A planned system ensures clean, safe drinking water, reduce the waterborne diseases, and ultimately we can improve the public health. See, this is the important. So if you are providing the clean water, this good quality sanitation, so what will happen? Ultimately it reduces the waterborne diseases. So means as we know, 90% of diseases come from the water contaminations. If you are providing the quality water, then improve of health also will be increased. Then environmental protection, if you are not means not polluting the water, means you are adopting some kind of sustainable principles, and you can means adopt some conservation of water resources, maybe rainwater harvesting kind of things. And during the irrigation process, during the watering period in the field areas, if you adopt the efficient means watering applications like drip irrigation or means sprinkler irrigation, we can reduce the amount of water used in the field areas. So what is the objectives of community water supply? What are the main objectives? First objective are means to provide the quality, that is the wholesome water to the consumer for the drinking purpose, to supply adequate quantity to meet at least minimum needs of individuals. Here means the first of all quality should be there, then as well as next step the quantity also needs to be maintained minimum. So quality plus quantity is required, that is a foremost thing. Then next one with the to make adequate provisions for the all emergencies like firefighting, festivals, meeting. Maybe means other than drinking purpose, there will be several factors it can influence. Maybe firefighting during the fire accidents is required, large amount of water is required. And maybe festival time also means consumption of water will be very high. So and meetings extra some other maybe water may be lost, some of the some quantity of water may be lost, depth also will be happen. So for that we need to provide some extra. So to make provision for the future demand due to the increased population, increasing the standard of living, the storage and convenience. See here means before construction a distribution network, we need to think about the future population. The population forecasting is required. So maybe population protection is required, and as well as the standards of living also will be increases. So what kind of standard livings? Maybe means 10 years back no one is in the washing machines. Nowadays everyone is in the washing machine. If you are using the washing machine, means it consumes a lot amount of water, so that will be converted as the wastewater. That means that will always convert as the municipal wastewater only. So if you are using the hand, then the quantity of water is required to wash the clothes will be very less compared to the washing machine. So the standards or comforts are increasing. The wastewater generation also will be increased. The last option will be the to design and maintain system that will be economical and reliable. These are the objectives of community water supply system. So what is the status of protected water supplies in India? So we need to protect, we need to provide the quality, quantity, and also means we need to see the some of the factors, that's why we need to provide some extra amount. Those things we discussed means right now what means how much protected water existed on the earth. See here covers around 90% of rural and 99% of urban areas in India have access to the protected water supply. Still, that means we are facing some of the problems. Those challenges, see, first one, unequal distribution. See, disparities in water supply between the rural and urban areas. So and also there will be due to the elevation means maybe the lake or pond, maybe reservoir, it is the lowest level means some houses are there higher elevation level. If you are supplying from that river to the means community, what will happen due to the means height of or maybe it is low to high, it is not possible to send water to the community area. That's why pressure will be varied. And also from rural to urban also the water quantity will be varied. In urban areas the quantity of water is required more compared to the rural areas. Then coming to the contaminations. So here means Many sources face contaminations, maybe lakes, rivers, even aquifer also faces the contaminations. Why it is means we are using nowadays more chemicals. Maybe in agriculture fields also we are using the means synthetic fertilizers, and also means sewage, that is the wastewater is coming from our bathrooms, kitchen. Those are meeting. Those are means disposed on the water bodies, and coming wastewater from the industries. Those are the mixing with the lakes, rivers. Those are the fresh bodies. That those also will be contaminated. That is one of the challenge. Then infrastructure issues. So here, inadequate maintenance, underdeveloped distribution networks in the remote regions. So in remote regions, so there will be no distribution network. So in that situation, means supplying water to the community is difficult. So for them means this kind of challenges, government of India is proposed some kind of missions. First one is the National Rural Drinking Water Program, NRDWP, aim is to provide safe drinking water in rural area. This mission is specially for the rural area. Then Jal Jeevan Mission, aiming to provide functional household tap connections to every rural home by 2024. By 2024, every house have installed try to set up install a tap. So what will be the water quality? So over 60% of groundwater sources in India are contaminated. So there will be several research articles published. The groundwater quality is degraded and deteriorated day to day. Because of this, we discussed what will be the sources of contaminations. Means maybe in due to the increase of solid waste, the means what are the waste is generated from the cities, we are means throwing on the outskirts of the city. That name is means we called as landfills. Because of these landfills, what are the leachate is generated during the degraded process, it will be contaminate the surface soil and groundwater. So maybe in air or means in means different industries also is polluting the water. Maybe domestic wastewater also is polluting the water. Maybe different sources means contaminate the surface as well as the groundwater. So generally this groundwater is contaminated with the fluorides, arsenic and nitrates. What will be the means future goals will be the so to improve the means water quality and reliable delivery, that is the foremost. Then promoting the means rainwater harvesting and wastewater treatment. So due to the increased demands, the wastewater means quantity also will be increased. So we need to apply the sustainability concept here, reduce, reuse, recycle. So if we means first option will be that try to reduce the usage of water if it is not required. So if we still it is required, we need to try to use reuse again. If it is not feasible or not means suitable the water for the means reuse, then we need to go for the recycle, that is called as wastewater treatment. Generally means before going for the treatment, we need to see the what kind of means characterization of wastewater is coming from the particular means sector. Maybe industry one sector, domestic is another sector, institutional different. Like this way, there will be different sectors. First of all, if you want to treat means wastewater, so wastewater is coming from, per suppose wastewater is coming from the domestic. Generally, domestic wastewater contain what kind of characterization? Here maybe paper may be there, plastic may be there, some kind of stones, some kind of inorganic materials, maybe BOD, some kind of oil. It is there. This is the means general typical wastewater characterization of, from the domestic wastewater. See here means how to treat. So I means I will tell you the typical wastewater treatment plan could be. First will be the screening. Here is the screening means what are the large objects that will be stopped here. Then remaining water will be sent to the next unit, that is a grid chamber. Here maybe inorganic material as the sand particles, maybe some kind of dust particle. It will be stopped here and it will be settled at the bottom of the tank. Next purified water will be sent to the next chamber, that is a skimming tank. Here whatever the oil grease, it will be there, it will be stopped, and it will be formed layer at the top of this surface water. So we can remove easily. The next summary will be the primary clarifier. Here, what are the suspended solids, remaining suspended solids, then some portion of BOD also will be removed. Here what we have to do means, here we need to provide the some kind of detection time, means what are the water is coming to the reactor, we need to wait for some a particular amount of time, maybe 15 to 20 hours, so that what are the impurities, what are the BOD it is there, it is try to remove from these reactors. Next will be the some kind of secondary treatment. Here we need to provide the aeration. So, and also bacteria will be there. Bacteria is try to degrade the BOD. In this process, it will be settled. Then some portion of the BOD will be sent to the aeration tank to maintain the microbes as well as the organic matter. This way, the wastewater will be treated. So, and also this is the wastewater, means we need to store water. So how to store water during the rainy period? So we can dig one pit, so that is called as rainwater harvesting. So that means this is the one of the efficient way to store the water. And also we can adopt some kind of wetland techniques. So means why it is helpful means, wetland will be restrict the flow of water. So what are the contaminants present in the water, it can uptake by plants, and remaining water get filtered, and it will be reach the aquifer. Here means what will happen, water won't flow on the surface, it will be stopped, it will try to infiltrate on the aquifer. So, what are the sources? Means we discuss the production, means and the quantity, quality, means what are the sources existed. So we know means the two major sources: subsurface sources and surface sources. Here, surface sources means rivers, lakes, impound, reservoirs, lakes. Subsurface means here infiltration galleries, infiltration wells, springs. Here, springs will be divided into three types: gravity springs and surface springs and artesian springs. Here, gravity springs, when the surface of Earth drops sharply, water-bearing stratum is exposed to atmosphere and gravity springs are formed. Next one, this is formed when impervious strata, which is supporting the groundwater reservoir, becomes of the crops. Then artesian cross spring means when the groundwater rises through the fission. Fission means, here means crack of the any rock, if the water gets out, that is called the artesian spring. So next one is the water quantity estimation. How we can estimate the quantity? For suppose in a city, in Warangal city, the population will be around 7 lakh, and then the per capita demand will be around 130 liter per head per day. Means how to estimate the Warangal city means water quantity. So quantity for a Warangal city equal to, so means we discussed already, population is 7 lakh, is a multiply with the per capita is 130 liter per head per day. So what are the intakes for the collecting of surface water? The main function of the intakes works is to collect water from the surface source and then discharge water so collected by means of pumps or directly to the treatment unit. So the main function of intakes is to provide highest quality of water from the source. That is a thing. So I will show you the means different types of intake structure. There will be different names: submerged intake, exposed intake, wet intake, dry intake, lake, reservoir, river, canal intakes. See, it is the submerged intake. What are the structure? This is the structure. It will be a kind of submerged in the water. That is called a submerged intake. So the water means is taking from here, then it will be sent to the treatment unit. Then this is the exposed intake structure. We see in several means pictures we seen in the besides lakes and rivers. It is in the form of well or a tower constructed near the bank of river, or in some cases even away from the river banks. This is called as exposed intake structures. Then wet intake structures, it is typically intake tower in which water level is practically same as the level of sources of water supply. See here, water level will be Here, then intake also means we are taking water from here also. That is called as wet intake structure. Dry intake structure. In case of dry intake, there is no water in the water tower. Water enters through entry port directly into the conveying pipes. It is usually for operation of valves. So water demand by sector wise. So water demands refers to the quantity of water required to meet needs of various sectors. Maybe domestics required, agriculture, industrial sectors, maybe some kind of institutional or kind of public areas required water. So this is the agriculture, industrial, domestic, environmental. So this is the demands we discussed. Maybe domestic, industrial, institutional demand for public use, fire demand, losses and kind of thefts also will happen. Then coming to the domestic water demand, for the means see the calculations how much quantity of water is required per head for the domestic purpose here. Drinking 5 liters, then cooking 5, bathing 55, washing of clothes 20, washing of utensils 10, washing of clothes, cleaning of houses, residences 10, flushing of water closets is 30. It's altogether 135 liters required and an average for the Indian people. So coming to the industrial water demand here, based on the means name of the industry and based on the production, the quantity of water also will be increased. See here in automobile industry, for designing or for making of one vehicle, it's required 40 kiloliters. So in fertilizers also to make of 1 ton of fertilizers is required 80 to 200 kiloliters. Like this way, textile also 1 ton is required 80 to 140. For distillery alcohol preparation, for 1 kiloliter of alcohol it's required 120 to 170 kiloliters of water is required. This is the means based on the industry, the means quantity of water also will be varied. For a domestic purpose is an average 135 liters per day. For coming to the commercial water demand, here maybe in commercial it may come offices, schools, hostels, hotels, hospitals, cinema halls. The water quantity per head it will be varied here from offices around 45, means coming to the cinema halls is very less, as means 15 liters per head per day. Hospital is required more water here for 450 liters per head per day. So here also apart from drinking purpose we calculated industrials also we know, we means we estimated, we understood what means how much quantity of water is required. And commercial also, schools, colleges, hospitals means public gardens require some quantity of water, those things also we discussed. Now we here means in the particular incidents, maybe fire accidents, it's required at a time large quantity of water is required. So for the calculation of this fire demand, uh, how much quantum is required, the three empirical equations are there. Here means American Insurance Association, the Nicotilling formula, Freeman's formula. Here equations are empirical, means that means what are the units existed for a particular parameter will be fixed. Here Q always should be in the liter per minutes, and one unknown parameter that will be the population p always should be in the thousand. If population will be given as 1 lakh, then p value should be 100. If it is given population as the 5 lakhs, then p value should be the 500. Then means after calculation the from the equation what are the keys getting, that value should be in always liter per minute. So water quantity by sector wise. So in previously we discussed for the means different sectors, but here altogether means what is the domestic water? It is required 65 to 300. Industrial and commercial demand it is required 45 to 450. Public usages maybe including fire demand, water loss. So every together 20 to 90. Losses and waste it will be around 45 to 150. So here we need to calculate the fire demand. How to calculate the fire demand? If the population is given as the 2 lakh, see here, read the question. Example 1.1. Compute the fire demand for a city of 2 lakh population by any two formulas. by any two firm, including the National Board of Fire Underwriters. See, this is the essential to calculate the fire demand. So Q equal to 4637 square root p multiply with 1 minus 0.01 root p equal to, so here the population in the question is given as 2 lakh, then p should substitute as 200. So 4637 square root 200 multiply with 1 minus 0.01 square root 200. Here whatever the calculated value should be around 56,303.08 liter per minute. So here we need to convert liter per minutes to the million liters per day. How to convert? So here liter means, so 1 million liter will be equal to 10 power 6. So the 10 power 6 it will be comes in the bottom 10 power 6, and the minutes we need to convert in the days. So here it will comes to the numerator. So here we need to multiply with the 60 minutes means 60 is 60 hours, then 24, so 24 hours and 60 minutes. So we need to multiply with the 60 and 24 divided by 10 power 6, it will give the MLD. It is calculated MLD will be 81.08 MLD. Next, we are using the formula, Cuchiling's formula. Here, the Q value will be 3182 square root P. So here 3182 square root of 200. Why 200 means already explained. The population given in the question will be the 2 lakh. Then whatever the answer we are getting is the liter per minute. The final, the Q value will be 45,000.27 liter per minute. Here also we need to multiply with the 60 and 24 divided by 10 power 6, that will gives the MLD 64.8 MLD. Now tell me what are the points we discussed here. The first thing will be the why, it means what are the roles of environmental engineers. So what are the roles of environmental engineer? To protect the public health. So in that we need to supply the quality water as well as the quantity is must required, and whatever the means objectionable matter is there, we need to remove it. And also means what are the sources existed, means we discuss surface sources, means subsurface sources, and it's kind of what are the surface sources, lakes, rivers, ponds, dams. These are the kind of surface sources. Means subsurface means here maybe means aquifers, maybe springs. So means these are the sources, but how we can take water? Before taking the water, we need to analyze the water, means in terms of physical characterization, chemical characterization, biological characterization. If we know this characterization, then only we need to put a proper treatment unit, so that the water means free of contaminants. Those water we can supply to the uh, community. Then means so means, and also we need to estimate the means before designing a distribution networks, we need to design a distribution networks. For that we need to forecast the population, and also standards of living is increased, means the quantity also needs to be increased. For that situation we need to forecast the population, and after means forecasting the population, we need to multiply with the per capita water demand, and after calculated value we need to multiply some of the factors, so that it will be included the taps, some kind of losses, and everything will be included. So these are the things, and means this slide we discussed about the fire demand, how to calculate, what are the equations are there, all are empirical equations, what are the units there for a particular parameter, it will be fixed. When you are calculating, the Q value will be always liter per minute. When you are substituting the P value, that should be always in thousands. For suppose a population in a city is given as 5 lakhs, then p value should be 500. If it is given 10 lakhs, the p value should be 100. Not 100, it is 1000. Like this way we need to substitute the values, and the final q value should be comes as the liter per minute, and after that it is coming as 80,000 or 45,000 or 50,000 per liter. It is very difficult to pronouncing, maybe telling this many liters is not a good idea, so that's why we are converting these liters to the mlb. So here using two formulas we calculate the fire demand. One will be the 81 mld is coming, that is the using of National Board of Fire Underwriters. Then the next cushioning formula used here is getting around 64.8 mld. So thank you very much. Next session we will discuss about the how to forecast the population.